Hello, this is Scott. Welcome back to my YouTube channel where I cover a variety of different data science and analytics topics in various different platforms. So today I'm going to talk about something that's kind of fun. It's called Anscombe's Quartet, and it really emphasizes the need to know your data, or certainly, just know your data. And one of the best ways to do that is to visualize the data itself. So this will be short, but I want to show you the data set that I have here. I've got four different sets, right? And I'm calling them plot A, plot B, plot C, and plot D. And I just created a simple workspace in the platform I'm using today is Statistica. And so I'll show you a simple frequency table, and I've already executed this. So again, here are those four categories. There's 11 observations in each category that are present. So if I run descriptive statistics on the columns, right, that's what this looks like. The descriptive statistics, this is for plot A, and let me just expand that. So mean 9 and 7.5, standard deviation 3 and 2. Here's B, and you notice that didn't hardly change when I switched to that. So column-wise, these are pretty much generating the same mean and standard deviation across all four groups. All right, so what if I looked at the correlations, right? So I can do the correlations within Statistica. By the way, one of the powerful things that I'm doing here today is I'm using this by group checkbox. I illustrated this in another video, but this is really powerful in being able to perform the same action across various groups in a multinomial or categorical variable. And so we're using that group variable that I showed you to do that. And if I look at the output here, the correlation, so what's the strength of correlations between these? You can see here the X and Y, simple correlation about 82%. Across all data sets. What about for group A? For group A, sure enough, it's about 82%. Why? Oh, looky here, plot B. This group is about 82%. This plot is about 82%. This plot's about 82%. So if I just thought about this data, it looks like it's generating essentially the same statistics. I would think that these groups are fairly homogeneous. And this is the reason that Anscombe, which he was a statistician, he came up with this to illustrate the fact that you really do need to visualize and understand your data. So if I were to look at the scatter plots, all right, so I'm just going to generate a simple scatter plot. I'm going to go in and I'm going to categorize by the plot, which is our variable, right? So the X category, if I were going to Statistica, X, Y, and plot is my category, and that's pretty much it. And then execute. And this is what I get. So here are four data sets, which the descriptive statistics seem to generate about the same. And you can look at the regression equations up here, very, 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 very similar for our linear fit. However, you can see that these are four very, very different data sets. So kind of cool, really. And of course, one of the other things, I could have done this back in the correlation matrix Excel, do that group by and select a couple of different options, one of which is the scatter plot matrix and color map. And then if I were to look at that output for group A, here again is my correlation, which we saw. Here's the plot for A, again, heat map correlations. Then if I look at B, sure enough, the same correlation, but very, very different distributions. So again, know thy data. I hope this was useful, and I hope you can join me again.